Welcome to Happy Path Programming. I'm Bruce Eckel.
I'm James Ward.
So we're here with Richard Feldman, who has been a huge, he wrote a book on Elm, which I have.
Nice.
And you have been huge into the Elm world, kind of pretty much after, I think
Evan.
Evan, you're kind of I don't know, my perception is kind of the biggest Elm booster, and you've said that you brought Elm to JavaScript programmers, which just sounds very challenging to me. And you've been working on this new programming language, just you and an open source community. Is that correct?
Yeah, I mean, it's not funded by anyone, if that's what you mean.
Right. Yes.
You and the community.
Otherwise, you would have a much fancier recording booth if you had funding, not your hall closet. Okay.
Yeah. I mean, it's all volunteers at this point.
Okay.
There's, I think, 50 people have made commits on the compiler right now, or to the repo.
That's
Yeah.
pretty good.
Yeah, so I saw your presentation on Roc from Strangeloop, and I was like, wow, this is really fascinating. And the thing that I think was most fascinating was a lot of times when I talk to people about functional programming, they've got their list of objections to just fundamentally to functional programming. And it seemed like a lot of the stuff that you're doing with Roc kind of blows up a lot of those fundamental objections. So I was just like, I love this. This is awesome. And we got to talk to Richard. So
yeah, it's very interesting, a lot of the things that you were saying, because we've been studying Scala 3 and Zio, and so all about effects, and you just kind of said, yeah, there's this thing, effects, and here's how we handle it. We have an effect system. But before we get too deep into that, I want to do basic stuff.
Sure.
Which is I just noticed that there's been a lot of 3-letter languages coming out lately, like Elm and Zig and Nim, and now Roc, which is also a 3-letter name. And I assume that's after the mythical bird from Greek. Yeah, okay. And how is that? What's the connection there?
Well, there's a couple of reasons. So first of all, I know why a lot of them are 3 letters. It's just because that's the traditional file extension length. So we want to be, .roc, .elm,
Yeah, I mean, that Scala just that's too many letters at the end of a file.
Yeah, but that goes back to the CPM days. I mean, it's that's not a...
It's right. It's definitely not a requirement anymore, but it's
just a convention. Okay.
I think at this point it's gone from convention to tradition.
Okay.
It's not even necessary anymore. But
so our source files in roc.roc.
Oh yeah, absolutely.
Oh, nice.
Okay.
Yep.
All right.
That makes sense.
And then the bird. What's the deal with the bird?
So for me, the connection is a couple of things. So one is that I like fantasy stuff. I used to read fantasy novels a lot.
That's very unusual for computer programmers.
I know it's yeah. I way outside the mainstream on that one. I used to be a competitive Magic the Gathering player, and there's a number of Magic cards named after Rocs.
We can cut this out of the recording if you decide you don't want that
to reveal that.
No, that's very public knowledge. I used to be known for writing Magic articles. Actually, I was on StarCityGames.com. I was part of their first crop of authors when they switched to a weekly column format. It was me and Jamie Wakefield on Thursday. Anyway, so I actually have I was at a conference at Strangeloop, funny enough, and they had a little Magic tournament, and that was the first time in a very long time that someone recognized me from my name tag based on Magic rather than open source stuff or Elm. Anyway, so there's that sort of connection, and then also I also like rock music and heavy metal and stuff like that, and I also like puns. So the pun potential for Roc as a programming language name is astronomical. I got a whole list of puns that I've written down.
Yeah, well, Python has certainly taken the punning or whatever, playing off of other things to an extreme with all the Monty Python references that they have.
Right.
Which,
yeah. Yeah, we will rock you. Yeah.
Oh, right.
I mean,
Yeah,
there's
exactly.
just so many good
Sure.
opportunities.
Oh yeah.
Rock the Casbah.
Yeah.
Oh yeah.
Is Casbah a place?
It's a. I believe a Casbah is like a. It's not a city. It's a particular kind of business or building.
So what I'm getting to is when we do a rock conference, we'll call it Rock the Casbah. Will be the name of the conference.
Right? Oh yeah. No, that would be good. That would be good.
Yeah.
Yeah.
So lots of good puns on
Yeah.
available.
Yeah, you could have a meetup group, Women Who Rock, right?
Yeah. That's so many great options there.
Yep.
Okay, so tell us about rock.
Yeah, what problem are you
We've
trying
seen-
to solve with this language?
We've seen the presentation, but our listeners may not.
Yeah.
Sure. So the short pitch is, I mean, the reason that I made Rock is I wanted an Elm-like experience in domains outside browser-based UIs, which is Elm's focus. So
Where
basically,
it rocks.
exactly. So I guess to be more specific about what that means, sort of the main goals of the language are it's a pure functional programming language with an emphasis on delight, like as in terms of like delightful user experience, simplicity, and speed, like performance. And that's both speed of the compiler and also speed of what it compiles to.
It
So
compiles
Rock
the native
programs,
code, right?
right, compiles directly to machine code. So same thing as like Rust or C++ or I guess maybe a better example would be like Go or Swift. In terms of like higher level languages. But it is, unlike those languages, it's a pure functional language. So there's no, I guess Haskell does this too, actually. So there's no VM, there's no bytecode. It's all just like as fast as possible, compile to binaries.
Yeah.
Is there a garbage collector?
So there's automatic memory management, but there is not in the traditional sense a garbage collector. This gets into the platforms and applications thing, which I'm sure we will talk about, but that's a whole digression. So maybe we should get to that.
Come back to garbage.
So could I
memory
use
management.
it, for example, to create like a Python extension module?
Sure. Any programming language that speaks C, you can like embed a Rock program into.
Any like foreign
if you want to
interface stuff.
Does it have a foreign function interface?
I wouldn't call it an FFI, but it definitely has interop. Or like interop is definitely possible. So actually, somebody already made they got Rock Hello World working inside Swift.
Oh, cool.
Okay.
Shritesh got that working.
So you could compile down to either a native executable or a native library, and if you compile to a native library, then you can bind it with whatever other language you want.
Mm-hmm.
Pretty much, yeah.
Cool.
And if it's because the experiments that I did with Go trying to create extension modules, Go had to have runtime. It had to have a runtime running. It wasn't just a standalone module.
Yeah, so Rock very intentionally compiles down to. I mean, I don't know. Should we get into this?
Yeah, we're interested in all this stuff.
Sure, cool. So, okay, so Rock as a language is unusual in a couple of ways. One of which is that, and maybe the most novel thing, because I literally don't know of any other programming language that does this, is Rock has a first-class concept of what we call platforms and applications. So an example of a platform is something like a game engine, where you have one game engine and there are many games, which are applications built on top of that. Or you have like a web server framework. That would be another example of a platform. There are many, web apps built on top of that. Or you could even have like a pretty bare bones one that's just like a CLI platform for building command line interfaces, and then you have many CLIs built on top of that. So when you build a Rock application, you have to pick a platform, and exactly one platform. There's no such thing as like a Rock application with no platform. In practice, the idea is that this feels just kind of normal, because in practice, that's pretty much what everybody does anyway. Even with languages that don't have this as a first-class concept, like you'll build on top of a web server framework or whatever. But the interesting thing is that in Rock, the platform is, as an application author, it feels like a framework or a game engine, where the entire API, like the set of primitives that it gives me to build on, they're all written in Rock. So it's a pure Rock API that I'm consuming as an application author. But under the hood, the platform is responsible not just for providing that API, but also for providing the low-level implementations of all those primitives. So if I'm a platform author, I'm writing not only Rock code, but I'm also writing low-level systems code like in Rust or C++ or something like that to implement all these
to do the
primitives.
binding to the platform that it's actually going to run against.
Right. So as an application author, I'm just writing Roc code. Like most people, you want to build a Roc program, you pick a platform, but you don't need to be responsible for knowing, Rust or C, any language other than Roc. You can just write your Roc code and everything's taken care of for you. It just feels like a normal high-level language in that regard. As a platform author, though, it's pretty different, and you have a lot more control than you would get in most languages with like a traditional FFI. So you gave the example of like in Go, you need to have like the Go like runtime, sort of spun up to do extensions. In Roc, it's almost the other way around, where rather than specifying like here is for the entire language, here's how garbage collection works, it's actually up to the platform author. There's a couple of different options they can choose from, and in some cases, they very directly get to implement. What does it mean to allocate memory? Like they get to literally write the function that does that. And what does it mean to deallocate memory? And the Roc compiler is going to generate calls to those, but it's completely up to the platform author, which means they can do some really cool memory management strategies that are sort of domain specific. Like a good example of this is you can make a web server where basically, if I'm writing the platform for this, I say, okay, whenever we do a request handler that the application author writes, we're going to give them an arena to allocate memory into. And whenever that web request comes in, we start doing allocations into that arena. And then when the handler is done and it sends back the response, everything that was done in there is now garbage. Like we don't need to keep it around anymore. So we'll just throw it away then. So we basically don't need to have garbage collection pauses at all. We're just like, when's the right time to get rid of this memory? Well, when it's done. And we also don't need to go trace and hunt it down because we allocated all of it into this one chunk. And so we can just say, well, there's nothing to trace. So just like that chunk is now free. Done.
Right.
So it's both more efficient than a traditional tracing garbage collector, and also doesn't have any GC pauses at all. So this is the type of thing that we can get from having this first class concept of platforms and applications. And so from like thinking about it, like in the context of embedding Roc, like I was talking about examples where you have a pretty big platform. Like there's a lot of stuff going on there, and it's designed to be usable for lots of different applications, like a game engine or web server. But you can also go the other way around and just say, you know what, I actually want to be focused on, like I'm writing a game, for example, and I want to spend a lot of time in like a low level language writing my game, but I also just want to do some little like embedded scripting or something, like a lot of games use Lua for stuff like that. Well, no problem. You can also just say like, that's my platform that I want to have a little Roc application that's just for, doing a little bit of scripting here and there on top of that. You can totally do that too. But again, either way, it's really like the person writing the platform is in charge of all that stuff. And whether you're like, that's me, I want to be in charge of all that stuff, I don't want to have a big runtime to spin up or anything like that. Or vice versa, you're like, I just want to build my application, I don't want to think about that, I want someone else to take care of that. Both of those use cases work in Roc.
So an example of this would be in some platforms like Kotlin multi-platform, you have to kind of almost pick a lowest common denominator that all these platforms that you're targeting have in common. And then in places where you want to expose specific differences to the different platforms, it gets a little bit wonky and the programming model feels a little bit weird. But in the case of Roc, it sounds like there will be at least one kind of web programming platform and a iOS programming platform and a Android programming platform and a game engine programming platform. And so in that case, you don't have to pick lowest common denominator to have access to everything to those different platforms.
Mm-hmm.
And they can be even more specific than that. Like someone might say, I'm making a platform that's designed for making games on iOS. Right. Or they could go the other way and say, I'm trying to make a platform for making games that's explicitly designed to work on multiple operating systems like iOS and Android and whatever.
So they
and then
choose what they want to do in their platform.
Right. And if they're going to do that, though, they are going to have to contend with like there are differences between those, targets. Right. So what are you going to do? But
it's up to the platform to decide what.
But it doesn't prevent them from accessing those things because they're not part of the common subset across platforms.
Right.
So, okay. So like if I was saying, all right, I would like to make a general purpose app and I want it to run under Windows, Linux, and Mac. Is there is there a way I could do that to minimize my, the code differences? Is there?
Yeah, sure. I mean, so from the Roc compiler's perspective, it doesn't care. If you want to do that, you can go for it. It's capable of compiling to Mac, Linux, Windows. Actually, Windows currently doesn't work yet, but it's not from any design reasons. It's just like we haven't got.
Yeah.
Currently, nobody who's working on Roc uses Windows, so we don't really have like a.
Makes it harder.
It hasn't come up yet, but obviously we plan to support it. And so basically, anyone who wants to target all those different options, it's really just a question of what is the API they want to come up with that makes sense across all of those, and that's always the big challenge, right? I mean, one of the reasons that I would cite as a big factor in Electron's popularity is that there's already an API that everybody agrees on, at least works. How nice that is or is not to use is a matter of taste, but it works across all those different targets. And I think that's a big part of the explanation of Electron's popularity. Is like that's a hard API design challenge.
Yeah, for sure.
So we're using LLVM for code generation?
Yes. So we use LLVM for our optimized backend, but LLVM is has a big upside and a big downside. The big upside is it's really good at generating machine instructions that are really fast. Has a lot of optimizations baked into it. The downside is that LLVM itself runs pretty slowly, so it makes your compile times worse. So we actually have multiple ways to generate machine instructions. So if you pass the -- optimize flag to the Roc compiler, it uses LLVM. If you don't, we actually have a number of work in progress code generators that don't go through LLVM, that just goes straight to machine code on either x86 or ARM or WebAssembly.
Just to give you a faster dev loop when you're writing your
exactly,
code.
Yeah. So your code doesn't run as fast, but when you're doing development, that's maybe the trade-off you want.
Yeah. I like that you think about that, because I've encountered language designers sometimes who don't think about the user experience as much, the programmer experience.
Well, it's definitely one of the things that I think Elm set the bar on was the developer experience delight and making that a focus. And I remember Evan's presentation on this topic from years ago, and it was pretty groundbreaking to say, like, as a language designer, we should be thinking about developer experience and making that delightful.
Right.
Yeah. And I think that's part of it. I think, if you have, like, Elm is probably most known for its really great error messages, which has inspired Rust and other languages now to sort of, follow suit. I wish Rust would also follow suit on the compile times, but oh well. But basically, I think that compile times are a really important part of making a delightful language. Like, if you're just sitting waiting for the compiler, that's just not a pleasant experience. So yeah, I mean, we actually, one of the targets that we have is to be able to, and we're almost there, we're close, but not quite there, is to be able to compile and run Hello World faster than Python does. So we're almost at Python's level, but not quite there. But that requires, and obviously, like, the bigger goal is, like, when you have a big project, it stays fast.
Right.
But in order to get there, there's a certain we have to really optimize, like, every stage of the compiler to be as fast as possible, because Python just has a lot less work to do than we have to do. Python doesn't need to type check. We are type checking. Python gets to interpret Hello World. We actually have to generate machine code and then run that. So, and there's, like, the platform and application aspect to it too. So
what's the Roc compiler written in?
Rust.
Okay. Interesting. So you're working a lot in Rust, and then I'm sure there's long-term plans to, like, rewrite that compiler in Roc at some point.
No, there are long-term plans not to do that, actually.
Oh, wow.
Yes, that's usually the loop. That's the hoop that everybody. It's like some sort of proof of concept for them.
Yeah, so my feeling on this, which I got directly from Evan, like, the Elm compiler is written in Haskell, and that's not just because Elm compiles the JavaScript, but also because, like, as Evan put it, it's like, well, if your language isn't designed to be great for building compilers, like, why would you settle, And, like, that's the thing. Like, to my mind, I wanted to have the Roc compiler be as fast as possible. I know, like, when Go rewrote their compiler into Go, it got slower. Why would I do that? I care more about user experience than I care about, necessarily saying Roc is a great language for compilers, and honestly, that's not really one of my goals for Roc. So
That's a really good point, because the Scala compiler is written in Scala, and I look at the Scala compiler code. I don't know if you've ever looked at it, but it is unlike any Scala code that I see anywhere else, because it's solving such a different problem than most users of Scala actually solve. And what's weird about that is that then the people that are working on Scala, they're writing very different Scala than the users of Scala write. And I think that influences some design decisions around Scala that maybe not for the best.
Interesting. I hadn't even thought of that angle.
Speaking of design decisions, make sure I got this right. I think in one of your presentations, you casually said, we don't have currying in Roc. Is that correct?
That's true. Yes.
Okay, why was that? I always thought currying was kind of an essential part of a functional language, but clearly you're saying no.
Yeah, so there's a couple of reasons for that. Certainly, first of all, it's definitely an unusual decision. I'm definitely aware of that. And it wasn't like one that I made casually. So among like functional programming languages in like the sort of the descendants of the ML language, which is like Robin Milner's language from 1970 something, they all have currying. And I think currying is conceptually very cool. And I've used it a lot in Elm and other languages. But there are three problems that I have with currying. The three reasons that I decided not to include it in Roc. So one is error messages. So if you call a function passing too many arguments in Elm, the compiler error you get is too many arguments. It's very straightforward. It tells you exactly what the problem was. If you call a function and you make the mistake of calling it with not enough arguments, the compiler can't tell you too few arguments because maybe you intended to curry it.
Right.
So what you get instead is you get this sort of downstream error that's like somewhere else from where you made the mistake. And it just can't be as helpful because like what you did is totally allowed. It's just, the compiler can't help you with that. So that's one reason. A second reason, which is actually not the most important of the three, but it is significant. But I always have to give that disclaimer because as soon as you bring up beginner friendliness, people say, it's because you're making a toy language. That's why. So I want to clarify that this is one of the reasons. It's a factor. I think the beginner experience is important, but it's not the only thing. So this is not the end all be all of the three factors. But so I've spent personally more than 100 hours standing in front of a classroom teaching beginners Elm. Like I've done a bunch of workshops. I've done like online recordings. I've done in person at conferences. I've done in person outside of conferences. Done like volunteer stuff for local groups and stuff. And there are two things that very consistently I've seen beginners struggle with, and like by the end of the workshop, I know that like some people get it, but most of the people don't get it, or they're just like, I don't get it, but I'm not blocked by it, so I'm just gonna not deal with it and move on.
Yeah.
One of them is JSON decoding. That's like a whole other topic, but but the second one is currying. Whenever and you can't really avoid currying coming up because if you look at the function signatures in a curried language, they don't look like they do in sort of tupled arguments languages. Like it's instead of commas between the arguments, it's arrows as if they were return values, and that looks weird. And if once you understand currying completely, it's like, actually, not only does that make sense, but obviously it has to be that way, and it wouldn't make sense to have commas. But as a beginner, it's just weird. And I've tried explaining it a few different ways, and it's always like a significant tangent in the middle of the workshop. And I can tell by the number of blank stares, like after the explanation, that it's like, all right, you're just going to let me go with it. But like,
this is a rough edge, and let's just.
But it's hard to motivate. The thing is, because I have seen currying enough that it's comfortable for me, but I still don't go, here's a place I can use currying. That just isn't at the top of my head. And it's like, how do you compel this feature to somebody when, you don't even, it's like, I don't know what the killer app feature for currying is. So
that brings me to my third objection to currying, which is that I think what a lot of people see as a killer app or killer feature for currying is something that I actually see as a downside. which is point-free function composition.
Mm-hmm.
If you want to glue functions together without giving names to intermediate arguments and stuff like that, and just say like A composed with B, composed with C and stuff like that, currying helps you out with that, because there are more ways that you can do that. Currying sort of facilitates it. My conclusion after having spent a lot of time with point-free function composition is that it's just a bad idea. It's just worse than not doing that. I know people disagree with me.
Point-free?
Sure. So point-free basically means like without naming intermediate arguments. Okay. So let's say I want to do like addition, and then I want to like add two numbers together, and then I want to take the result of that and grab that many elements out of the beginning of a list. I don't know. I just made that up off the top of my head. It's not necessarily a useful function. So one way I could write that is I could write a function, and I could say, give me the two numbers, and then give me the list, and then I'm going to write out sum equals, x plus y, add the two numbers together. And then I'm going to say, I'm going to return, take the first sum elements from the list. And that's how I'm going to write this out.
You have one function that takes all three parameters.
Right. Extremely straightforward code. Another way I can do that in like, I'll say Haskell, because this is a popular thing to do in Haskell, is I can just say, well, I've got the ingredients that I've got here is I've got a plus function like addition, and that takes two arguments. And then I've got like the take function, which takes a list and a number. I can just glue these together using a higher order function composition operator without ever naming any of those intermediate things. I can just say, those are my two functions, and I can compose them together to make this thing that I want. You could do that. That's totally a thing you could do. But is that better code? Is it better to say like plus, like compose plus and list.take? Is that, it's more concise? Yes. Is it better though? My conclusion is that whenever I have written code like that, and then even just me, let alone other people, but I come back later, I end up having to desugar it in my head to understand what it's doing. Like I end up writing out the longer version, but instead of just seeing the longer version, it takes me longer because I have to actually, and usually I feel embarrassed about needing to do this. Instead of like writing it out by hand, which would probably be faster, I try to do it all in my head, as like trying to convince myself that like this was worth it and it was a good idea. And then eventually, after enough times doing this, I was just like, why am I doing this to myself? Why don't I just write it out the way that I can just scan it and just load it directly into my brain instead of having to. Yeah, exactly. Like I know that naming things is hard, but like it's just
yeah, but it's reading things that aren't named is even harder.
Yeah.
So basically, currying is just another way to create functions.
Yes. Well,
okay.
I mean that is literally what it is. I mean it's kind of the other way around. It's like they already were functions, but anyway. Yeah. So currying facilitates that sort of point-free function composition. It makes it so that there are more cases where you're able to do that. But since I'm like, I want there to be fewer cases where you can do that because I don't think it's a good idea. To me, like removing it is in essence, in part, removing a foot gun, because it reduces the temptation to sort of follow this pattern that I've concluded is
I guess there's always a
tempting mistake.
There's always a balance between going for like the most concise syntax and then the trade-off to that, which in this case is the mental overhead of parsing that concise syntax in your head versus not having the concise syntax and not having to do the mental parsing.
Well, and when I think about functional programming, well, the kind of main thing we do is make functions. This is another way to make functions, but if we have a choice between doing it this way and doing it some other way, well, then it's not an essential feature.
Yeah.
So
I have very, very rarely in Scala done this method of point-free method of creating new functions.
I think the only time I've ever used it is when I explain it.
Less than a dozen times in my Scala career. So.
But I just never thought of it as a way to create functions. And so, that changes things. Okay, well, that's cool. Simple. I like the fact that you decided to keep things simpler, and so this way, the syntax of function definition it
looks like it does in most languages. I mean, there's just commas between the arguments, and that's it.
Yeah. So
and there's one way to define functions. You can't like create new functions by using current. There's no, like you created a new function by defining a function, not by doing some compose or and then or something on a given function.
Well, I presume there's also, that you have lambdas.
Yeah,
to create unnamed functions.
To be clear, you still can write a compose function. It's just only you have to pick how many arguments you're composing together. You can't, right? Like you have to say, like, this composes two functions, both of which have exactly two arguments or exactly three arguments or whatever you want it to be. So it's not like it can't be done, but it's just it's obviously discouraged because it's not as flexible as what you would have if you had currying.
Yeah. So the other thing that you have is you've just kind of incorporated effects as a native idea in Roc. Well, and James got an interesting tweet directed at him this week, which you don't have to read the. We can keep this family friendly. You can just paraphrase it.
Nobody cares about effects. Stop trying to market effects to me.
Yeah,
things are perfectly fine in my world of Node.js and.
Right. Yeah.
I don't need effects.
That's
what the tweet.
So how do you? Because you do a lot of teaching. How do you explain effects to somebody who's never even considered
and
the
why?
concept?
Yeah. Why do we need?
Well,
them?
Interestingly, I think if you are familiar with Node.js in particular, I don't know that I would need to market effects to someone in that boat, because I think you could just say, well, instead of promise, we have a thing called task, and then separately, by the way, we have these other rules in the language. Like, actually, I don't even need to say the other rules. Really, if you're used to promises and you want to use the equivalent of task in Roc, I actually don't think there's really much learning curve there, because your program ends up being structured basically the same way. It's just instead of chaining together promises, you're chaining together a thing called task. What might feel weird is that
the whole thing and be like, effects are basically going to give you what you have with promises, and so don't worry about the fact that these are pure functions and we have a effect system and all that. That's just an implementation detail.
So essentially it just might feel kind of weird that, in Node.js, you have sort of two versions of every function. There's like the promise version, and then there's the synchronous version that doesn't return a promise. Whereas in Roc, you can't have the synchronous version. So it might seem weird that no matter which platform you pick to build on, all of the stuff they expose is always async friendly. Like maybe another way of saying is that it feels like everything is async, like every possible effect is async. And that's just the rule. I think that'll get you like 95% of the way there. There will still be some weird surprises, such as random number generation. Definitely won't work the way you're expecting it to, because people are used to just calling like math.random or something like that. Just give me a random number, which in Roc, you either need to model that as an effect or give it an explicit seed up front, which you need to have gotten somewhere, probably from an effect like give me the current system time or something like that. So that's something that like doesn't occur to a lot of people as being not a pure function. Yeah. But it is. I just thought I was just at GoTo Copenhagen, and I met up with Chris Jenkins there, who gave me an amazing explanation of what a pure function is, or how do you tell if you've got one, which I've never heard a better one, which is basically this. The way to tell if you've got a pure function is, can you replace the entire body of the function with a lookup table that just has a lookup from arguments to return value, and that's it. It doesn't do anything else. That's all the function does. Give me these arguments, and then I will give you back the return value in the lookup table. If you can do that, granted, assuming this lookup table might be absolutely astronomically large, but pretending you don't have to worry about memory or any of those considerations. Conceptually, can you replace the entire function with a lookup table? If so, it's a pure function. If not, it's not a pure function. And that's it. That's the whole test. It's just yes or no.
That's a lot better explanation than my mathematical one.
Well, it does sound like another way to define referential transparency.
Right. Yeah.
Which is based on the use of it rather than the definition of it.
Right. But this way you can imagine it.
You don't even have to get into category theory.
No.
Right.
You can just say, oh, okay, yeah, it's a table. It's every value can be cached, right? And it's not going to. Well, the ultimate thing is and it doesn't change from one from
Yeah.
one lookup to the
Yeah.
next.
Yeah. Nice.
Yeah. So I saw that it looked like you had sort of like so Scala has its for comprehension, and
Mhm.
you have something with backward arrows, but it didn't seem like it was for, and there was no yield. Is that right?
Yeah.
Like
So
your
this
cue
is
notation.
this is Rocs backpassing syntax. I would say that backpassing is kind of similar to like async await in a number of languages. It's basically for like, I mean, that's what it's designed for. Although you technically can use it for other things. It's basically when you're like, okay, I want to introduce some sort of ordering here between like asynchronous effects. Like I want, and in
Sequential.
Roc, all effects are asynchronous. So, but it's basically like, yeah, but before continuing, I want to wait until this thing's done.
Yeah.
And that's what it's for.
Okay. And so Roc is, it sounded like you said before that it's async from the ground up.
Semantically, yes. That turns out, well, I mean, I don't want to quibble about semantics, but basically, you could say it another way as like, if you want to do effects in a pure language, the way that you have to do that pretty much ends up looking or having the same characteristics as modeling async stuff in like an imperative language. So I think it's a nice shorthand way to think about it. Like all effects in Roc have to be async friendly because it's a pure language.
Right. Is your effect system based on monads or some algebraic effects, or what's the?
Yeah, it's just basically like like in Haskell they call it IO. We have a similar thing. We just call it effect. So we're not doing algebraic effects. I thought about it. Jared Forsyth gave me a very compelling pitch, which I thought about, but ultimately decided was not like the right fit for a Roc. We could go into why not, but like I know like Unison is also doing algebraic effects.
Yeah, we talked to Runar a couple episodes ago, and so he has
nice.
a little more information on the algebraic effects, which was mind blowing. But yeah, I don't understand much of algebraic effects. I understand monadic effects.
Yeah,
So,
Runar and I used to work together actually many years ago.
Oh, really?
Yeah. So he's been telling me about Unisons for a long time.
Yeah. Well, it's cool to see Unison and Roc both make effect systems a core part of the language, and that's what's super intriguing to me. Is all right, the stuff that is really on the fringe of modern effects, is separating out pure functions from effects is really important.
Right.
Yeah, I mean, I think if you want to have a pure functional language, there's no choice. I mean, it's either that or don't have any effects and then don't be useful. So if you want to be useful and pure functional, you got to have some sort of
Yeah, I mean, in
notion of
Scala,
effects.
it's not built in. Like there is no effect system built into Scala. But then, of course, like Cats and Zio have evolved to handle that.
But you can do side effects in Scala, right?
Yeah.
At least that was true the last time I used it. Yeah.
Yeah. The core language doesn't have any concept of effects. So
yeah. So if you want to have that restriction, I think it's a must.
Yeah.
How do you report errors? Do you use exceptions, or is it purely effects, or do you have a panic?
Yeah. So there's no exception system. There is a panic, but it's just for stuff like we ran out of memory. It's not like there's no throw, right? It's just like that can just happen behind the scenes if something
die.
Exactly, right. But that's not like a user space concept. That's just like, things that can happen in like the standard library if something overflows or whatever. So those are unrecoverable. So the way that we do error handling is there's a couple ways. So for non-effectful things, basically, we have sort of optional sum types. So like in Elm, this is called result or maybe. Basically, same idea, or similar idea in Roc. It's a little bit different, but same basic idea. Like we don't have like nullable or anything like that either, or null for that matter. It's really just like some operations.
Yay.
Yeah.
The future looks so wonderful. Nulls in the future.
Yes. So like some operations can fail, and the way that they fail is like with a sum type that you pattern match on.
Nice.
So with effects, and I guess this is also true of non-effectful things, but the way that we ended up with this was because of effects. We have this concept of they're basically like anonymous sum types. We call them tags. So like for example, in Elm and Haskell, the way that you would define a sum type is you say like, okay, here are the different, this type can be one of these several different options. So to give an example of results, you'd say like, I have two variants. There's an okay variant and an error variant. And both of those have a payload. Like okay is like, okay. And then there's also the thing that succeeded. And then the error is like maybe a string or something for the error message.
So it's an enumeration basically.
Right. It's like
some types are typically implemented. Yeah.
Yeah. So it's like an enumeration where it's not just like an integer behind the scenes. It's like you can have a payload, associated with each enum variant.
Class can be generic and all the wonderful stuff of classes.
Sure. Yeah. So we do that for non-effectful handling, and then for effectful handling, we use this feature where we actually have anonymous sum types. So you can actually just, without declaring anything, just start writing out okay and error, and the compiler will just infer based on your usage, like what is the set of all things that could be put together based on how you're constructing it and how you're pattern matching on it.
Wow, that's cool. I think Scala 3's ADTs are a little bit similar to that, but
okay. I actually haven't done any Scala 3. When I used it, it was back in the day.
So now they have specific ADT syntax where you just say like foo or bar or cat, and then it creates an anonymous sum type for
okay, cool. Yeah, so you can do that, and also, you don't even have to put that; it'll just infer it. But yeah, if you want to, you can put that in the type, just to enumerate them without declaring the type and giving it a name. So that works. But another feature of that that sort of falls out of that is that you can also have open and closed unions there. So a closed union is the traditional algebraic data type where it's like you can have these things and that's it. There's no other, if I say like, okay, an error, and then I try to put foo in there, it's going to be like, that's an error. Foo is not one of the recognized ones.
And then in your pattern matching, you have to, in a closed one, you have to catch all the possible types.
Right. It has to be exhaustive. So you have to, every single one that's listed, you have to cover it. So an open union, in contrast, you actually can add in extra ones, but the trade-off is when you're pattern matching, you now have to handle like sort of an else case. You have to have a default that's like a catch-all.
Yeah.
One other important thing is that you can, for most of your program, be going through and having an open union, and then at the last minute, you can turn that into a closed union and just say like, oh, you know what? Like right here, I'm just going to make it closed, and like from here on out, it's not allowed to have any other possibilities.
Is there inheritance in Roc?
No, not in the traditional sense.
Nice. So you don't have to worry about invariance and all variance and
like covariance, contravariance. No, none of that. So one of the cool things that falls out of this is that what we do for error handling is we will say, okay, for example, let's say I'm reading from a file. So that would be like a function that's like, give me a string. Let's say I want to read a file as a UTF-8 string. So I'd say, give me a string for the file path. And then I'm going to return a task. So this is like our equivalent of promise, kind of. And that task on success will have a string. And on error, it will have an open union of like file read error. So the relevant part about the open union part is that if I then have like an HTTP request, which maybe also gets a string and then also has a different open error union, such as maybe that would be called HTTP error. When I get that back, if I chain those two together, like I say, do an HTTP request and then do a file read, those will get unioned together because open unions are allowed to combine. So you end up with a new task, which has, the whatever string or whatever you're getting out of this.
All the possible.
And then exactly all the things that can go wrong just in one union.
Yeah.
So as you do more and more effects, chain them together, you just naturally end up with this accumulation of potential errors. And at the end, you can just do one pattern match to handle all of them and just say like, oh, here's all the things that can go wrong. Got it. And that works with like exhaustiveness checking and everything else.
Yeah.
So based on that, it then becomes possible to essentially have all of the sort of the nicest parts about exception handling, which is to say like not having to handle everything, like immediately, being able to sort of defer and say, you know what, I don't want to handle this yet. I want to just like kick the can down the road. But without the control flow parts where you're doing like, throw and catch and stuff like that.
Yep.
So that's how it works.
That's cool.
Mm-hmm.
And then recovery becomes easy and kind of universal. Is like you've got a task and you can in your recovery be like, all right, I'm going to apply a retry to this task, and
Sure.
if the retry, or the retry can say, all right, I got an HTTP, error, so now I'm going to retry against, let's say a different host or something like that, and then kind of absolve that error out of the union of the error types.
Right.
And so when you retry, all of the messy details are taken care of for you.
Potentially. I mean, it depends on who's writing that retry logic. But from a language perspective, I guess the relevant part is that errors can accumulate, so you don't have to handle them one at a time. You can handle them in a big batch, and also if you want, you can silently discard them, which is usually not ideal, but you can. And then as far as like individual HTTP versus FILO versus whatever APIs, that's entirely up to platform authors to how they want to implement those for their particular platforms.
Do you remember my tweet about how I'm going to start judging all programming languages by how yucky it feels to ignore errors? The yuckier it feels, the better. So it sounds like Roc it's going to be one that I love because it's going to feel yucky to ignore errors. I like that.
Well, yeah. I mean, it sounds like you have to handle them. You can't just at some point you have to say, yes, I'm going to handle this error.
Or
you definitely
choose to explicitly ignore it, but you have to write that code to
yes,
and it should feel really yucky if you do that.
Yeah, agreed. I hope it does feel yucky to ignore errors.
Yeah.
So one of the things that I noticed that you did in a couple of your presentations is that you showed this editor that you had written in Roc for editing Roc. And my immediate thought was, I feel like we've solved that problem. And also I already know how IntelliJ works. So is there some reason that you would use your own editor instead of adapting IntelliJ? And
oh yeah,
or VS Code.
Is
it VS Code based?
Yeah.
So the editor is it's actually written in Rust. The plan is to get Roc involved in there, but for writing plugins, not for and maybe some parts of the UI like settings pages and stuff, but like all the performance intensive stuff we want to be in Rust. Yeah, basically the goal behind writing the editor is that we really want to try and just push the boundary of like what editors can do. Like the goal is that people, like once we're done, we've like shipped the sort of the full working version of this, that it just becomes like sort of a new gold standard for like editing experiences.
Yeah.
And in particular, we want to try and achieve that by making it a language specific editor, like what you see in like Smalltalk or something like that. Like this is just for editing Roc code. It's not trying to be a general purpose IDE, because I think if we don't have that focus, we don't really have any hope of achieving the ambitious parts of the design.
I can see that. Like we haven't really seen anybody take a pure functional language with an effect system and really push the editing development experience around that, because there's so many amazing things you can do. Like I think Elm has that like web-based thing where you can do like time traveling debugger or whatever it is. You can do all this amazing stuff when you get into pure functions, and we've only I think like scratched the surface of what that code editing experience can be once we've got this foundation.
So that
was written in Lisp. So
I mean that is absolutely part of it, is just like pure function, like having a pure function language gives us a lot of like interesting things we can do that we couldn't do otherwise, that are sort of like safe to do, but wouldn't be safe to do if you can launch the missiles at any time by executing that code. Like time travel is one of them, like replay in general, but also just even like speculatively executing code, like just being like, well, you wrote this function, I'm just gonna like pre-fuzz it for you and just grab a bunch of inputs and just show you what the outputs are, and you can just like play around with that and graph it, and like I don't even need to ask you for that because I know that there's no chance this is going to launch the missiles. It's just it's just a pure function. It's a lookup table, it's fine.
Exactly right. Yeah, you can do what's the property? Is it property-based testing where it just like throws a bunch of values at a function and so like why not have your IDE just kind of doing that proactively for you. It's like, I know what types this thing takes, and I know what functions there are, and let's just start throwing values at it and showing you what happens.
Yeah.
Okay.
So,
well, that's good to know. It's not just a proof of concept.
Well, so I haven't even gotten to the big part. So the big
Okay.
idea with the editor is this is something that I don't know of any language that's ever tried to do this as a first class thing, but it seems like there's a huge amount of potential to it if some language were to be able to pull it off. So I think when I look at what has been like the big thing that's like been a really big improvement in terms of like productivity, or I don't know, just generally increasing the effectiveness of like programming languages in the past like 10, 20 years, I have to point like the number one overwhelmingly biggest thing is package managers. It's
Yeah.
like if you look at like, you know, in the 90s, like what did code sharing look like versus what it looks like today? Today it's like, how do I do this like really complicated, you know, cryptography algorithm? Like, it's like, oh, I just pull a package
global
off.
reusability
Right.
is a significant change in productivity.
Yeah.
I would definitely put it in like the top 3.
So I look at that and then I think about, okay, so what does our editor tooling situation look like as far as like help that I get from an editor? And I think that if I look at individual features of editors, they're in a lot of cases like very, very helpful. Like even something like when it works properly, like, you know, refactor, rename, like that can save you a huge amount of time to just do that transformation across you know, an entire code base. Step debuggers, like where you can actually step through, you know, one at a time. Like if you have one versus if you don't have one, that can be like, you know, most of the time people use print line debugging anyway, but having access to that, like, you know, sometimes print line debugging is just way, way slower than having a like a proper debugger. Things like that, or like for performance, like you know, heat maps and stuff like that. Being able to just see like or a flame graph of like you know, like what things are taking however long. But all the things I just mentioned are extremely general purpose. They're sort of like lowest common denominator. Like every language can use rename, every language can use step debugging, every language can use a flame graph. Where's the domain specific stuff? Like where's my tool for this particular framework that I use, or even this particular library that I use? Like if I get a regular expression library, why don't I have an editor tooling thing that lets me? Because regular expressions are like, you know, write once, read never, right? Like they're difficult to like keep in your head. So why isn't there a tool that lets me just say, here's my regular expression. I want to just play around with it. I want to throw some inputs at it. I want to scrub through and just see what it's capturing, help me debug this thing, and then like understand what it's doing. The closest thing I can think of to that is like there's like a website that's for just like regular expressions in general. It's not built into my editor. It's not language specific. It's not library specific. It's like, you know, they might have a checkbox for like pick your regular expression flavor. Do you want the Perl style or the JavaScript style or whatever?
Another example similar to this that I experienced recently was, I think it's an Android lint. They allow libraries to contribute lint rules to the linter. And so all of a sudden, like you just pull in a library, you run the linter, and the linter isn't just like you're saying, like general purpose. The linter then comes with rules specific to the libraries that you've pulled in, assuming that the library authors have added the lint rules in. But you're saying, let's take that idea and take it all the way up to the actual IDE, where the IDE can have library plugins essentially. So if you're a library author, all of a sudden you can also ship a plugin to the IDE as well.
You got it.
And provide better tooling for your library.
And the goal is to make that seamless. So like I install a package and I just get the editor plugin that come with that. And the goal is not just to make that possible, but to actually make it a cultural norm where like when you make a package, like it's kind of expected that it's like, I'm going to make the code and I'm going to make the documentation and I'm going to make the plugin.
Yeah.
I think that can only work if, number one, it's really easy to make plugins. Like, I think if we're going to be like, look, everyone in Roc, just everyone standardize on VS Code or IntelliJ or Vim or Emacs, right? Imagine that, right? And then just learn, you know, Vim script, or learn like, you know, even if, you know, you don't like writing JavaScript. Well, if you're going to write VS Code, you gotta do, you know, JavaScript syntax. I'm sorry, but like that's what you got to do. That's what all the APIs are in. No, the goal is to make it so that all of the plugins are written in Roc, so you already know the language. The API is really easy, and it's not even like you're going out of your normal workflow to like learn this totally separate thing. It just feels like writing any other Roc program. It's just like right there in the editor. Yeah. So make the barrier really, really low for making great editor tooling and make it so that it's really easy to share that tooling with everybody else. So the hope is to try and create a virtuous cycle where like you just have all these benefits, which causes everyone to choose to want to use the Roc editor anyway, because it's got all the nicest tools. And of course, there's also the other benefit of like, there's nothing to set up. It just ships with the compiler. You just type Roc edit and there you go. You got syntax highlighting, code completion,
cool.
you know,
That's like
everything. It's just, it's just right there. And then because you've got all these great things, that encourages more people to use the same editor, which encourages them to build tooling for that same editor.
Yeah.
Like I think one of the reasons for the lowest common denominator right now is just like, you know, if I want to, let's say I want to build tooling for Rust. Well, which editor am I going to do it 5 times for you know, VS Code and IntelliJ and Vim and Emacs and so forth? Right, it's just too much of an ask. I just wouldn't do it. And sometimes you do see, you know, fragmented tools, like someone will build one thing for just one thing, but you don't, that's not how you get an ecosystem. So I want to try and that's the reason for building the editors. Like it seems like the way to get to that world, which seems like an amazing world, is to try and set that as a cultural norm, like really, really early on in the language.
Oh yeah, those norms that you establish at the beginning are super important. I mean, people who are in communities that are in turmoil sometimes, because I've had a long association with the Python community, they'll often ask me, how does Python have such a nice community? And it was because it was established early and reinforced constantly.
Nice.
So that's an important thing. I mean, I can imagine just from seeing the kinds of things that you do, I can imagine that you've been thinking about, you know, how do we create developer delight? How do we create a community that's just friendly, that doesn't drive people away for any reason? Well, and on that subject, since you've been doing lots of Rust programming, you're obviously familiar with the amazing Rust book that comes, you know, it's just part of their documentation. So I would guess, have ambitions around creating something like that for Roc.
Yeah, I mean, Elm's also got a great like guide. It's just like guide.elmlang.org. Really well written and just a great way for people to get started. I'm actually in the process of writing the equivalent of that for Roc. Like that's my project at the moment, is like just writing a beginner tutorial. It's not a full book, but it's just something to just be like, hey, here are the basics of the language. You know, let's give everybody a way to get going on it, especially because we got Advent of Code right around the corner, and I know there's a couple of people who already expressed interest in doing Advent of Code and Roc. So,
doing Roc for Advent of Code. That's cool.
So giving them something to build.
Where is Roc at today? Like can people try it, and what should they do? Where should they go?
Yeah, sure. So anyone can try it. It is in a private repo right now, but if you want access to it, just email me, just roc@rtfeldman.com, and I'll just give you access. There's
ROC.
Yes, ROC at rtfeldman.com.
Why is it private? I think you're going to answer that.
So there's a couple of reasons. One is basically trying really carefully to set expectations. Like one of the things I remember from the early Elm days was that a lot of people got really excited and started like using the language, maybe overcommitting to it before it was like really ready. And then when there were breaking changes, that was like especially painful for people. So I want to in part say like, this is so not ready for production use that like, it's not even in a public repo yet.
Sends a message.
Yeah. And then the second reason has to do with that editor culture we were talking about, is that I want to give the editor like the best shot possible at achieving that like virtuous cycle. So I want to try and make sure that like everybody who comes into the repo has that context ahead of time and is like not, for example, going to be like, hey, guess what, everyone, I made a language server plugin. Like I really want to try and just like focus everybody on like, let's make this editor great. Like once it's all out and it's all released and everything, like, okay, I'm sure someone will make a, you know, language server plugin or whatever. But like right now I want to try and like even the odds and like give it a fighting chance to like, you know, get that like realize that goal. But so my plan is basically like once we have the package ecosystem with editor plugins, like once that part of the project is like built and shipped, then I'm like, cool, let's make the repo public. But actually already has a permissive license in the repo. It's just like, you know, it's just for for cultural reasons and expectation setting.
Cool. Well, I think you've got something in the oven. You're baking, not just the Roc language, but you need
Yes.
to go get
Literally
whatever
baking.
out of the oven. But thank you so much, Richard, for joining us. It was really fun to hear about Roc, and I look forward to trying it because I haven't yet. So
yeah, it's pretty fascinating.
Yeah, I mean, send me an email. You can try it out right now.
Awesome. Thank you.